Hello and welcome to this third and final part where we're running through the AQA GCSE Maths exam paper from the foundation tier in November 2019. This is paper 2 and it's a calculator paper. We left off on question 21, which means we are now on question 22. Question 22. Here is a cuboid. The two largest faces are blue, the other four faces are green. Is the total blue area greater than the total green area? You must show your working. This is about spatial awareness and understanding what shapes look like from different directions. From this shape, the two largest faces will be the top and the bottom because their dimensions are 9 by 5. When you compare that with the other sides, the front and the back will be 9 by 3. And the two sides on the left and the right will be 5 by 3. So starting off with the blue area, that's the two rectangles on the top and the bottom. Well, if you look at the bottom, you can see that each rectangle will have a length of 9 and a width of 5. 9 times 5 will give each of those areas 45 centimeters squared. We have two of them, one on the top and one on the bottom, so the total for the blue area is 90 centimeters squared. Now let's deal with green. Now for green, we have two different pairs of rectangles. We have the front and the back, which has a length of 9 and a height of 3, which gives us 27 centimeters squared. Once again, since we have the front and the back, we have two of them, so that will be 54 centimeters squared. We also have the left and the right rectangle, which has dimensions of 5 by 3, which would be 15 centimeters squared. And finally, since we have two of those, we'll have 30 centimeters squared. So in total, the blue area is 90 centimeters squared, whereas the green will be the 54 plus the 30, which is a grand total of 84 centimeters squared. And so yes, the blue area is greater than the total green area. Question 23. The result of a game is win, lose or draw. After 80 games, relative frequency of the result win is 0.4, relative frequency of the result lose is 0.25. How many of the games had the result draw? So we're trying to find out, first of all, the relative frequency of getting a draw. You could work out how many of those games were won and how many were lost, and then subtract the answer from 80, but I'm going a separate way. So the relative frequency of winning is 0.4, the relative frequency of losing is 0.25. So far, we've dealt with the relative frequencies totaling 0.65. Relative frequency, as with probabilities, must total 1, which means we can do 1 minus the 0.65 to say that the relative frequency of drawing will be 0.35. We now actually need to say how many games that represents. And you have two ways of doing that. You can either do the calculation of 0.35, the relative frequency of drawing, multiplied by the number of games, so the number of trials. That will give us the correct answer. Or you could recognize that 0.35 is the same as 35%, and you can work out 35% of 80. That's your choice. If I was doing the percentage method, you could say that 10% represents 8, so 30% would represent 24. 5% is going to be half of 10, so that's going to be 4, which means in total, the 35% for drawing will be 28. And that is the same answer you would get from doing 0.35 multiplied by 80. So 28 of the games had the result draw. Question 24. Work out the lowest common multiple of 120 and 144. First of all, let's understand what it means by lowest common multiple. A multiple is a number that appears in its times table. You can always remember that because it is one letter difference from the word multiply. If you swap out the E for a Y, it's all about multiplying. When we are looking at the times tables, we are now trying to find the lowest, the smallest number that is in common to both lists, so that appears in both lists. To begin with, I often start with the larger number, and I'm just going to write out its times table. So 1 times 144 is 144. 2 times will be 288. 432 is 3 times. 576 is 4 times, and 720 is 5 times. If I do the same for 120, 1 times 120 is 120, 2 times is 240, 3 times is 360, 4 times is 480, 5 times is 600, and 6 times is 720. You'll now note that 720 is the smallest number, the first number that appears in both lists of multiples, and so 720 is the lowest common multiple of these two numbers. There are other methods that you can use to try and work out the lowest common multiple involving prime factor decomposition, but this method will work equally well. Question 25. The scatter graph shows the best high jump and the best long jump for 15 boys. Write down the type of correlation shown. So the correlation is some sort of link between the two values. If the points tend to be going upwards from left to right, as these points are, then you will just give the answer of positive. This is positive correlation. You can also have things like strong positive, which is where the points are very closely aligned together. So this, I would say, is an example of strong positive. But you can also have a weak positive if they're a bit further apart but still going upwards. If the points were going downwards from left to right, then we would have negative correlation. And if you couldn't draw any form of line of best fit, or you couldn't tell what direction the points were going in, then it would have no correlation. 25b. Liam has a best high jump of 166 centimeters. Use a line of best fit to estimate his best long jump. So we need to draw a line of best fit onto this scatter graph. If you just write down an answer without a line of best fit, you will score 0 marks because it is telling you to use a line of best fit. Now, when we draw a line of best fit, don't assume that it's always going to go from 0. In this case, there is no line of best fit for these points that go through 0. Instead, you are trying to put the line in such a way that it is going in the same direction as the points. If you can get it going through some of the points, brilliant. But you can also try to even out the amount of points that are above the line and the amount of points below the line. Different people may have slightly different lines of best fit, which means that their answers will come from their lines only. So you might get a slightly different answer to me. Now we need to use it. So the best high jump is going to be 166 centimeters. So we need to go to 166 and we need to go straight up to the line of best fit. Once we are there, we go directly across to the other scale, and then we need to read this off. So for me, that has arrived at 1 square above 530. Since there are a total of 5 squares between 530 and 540, that means each square has got to be worth 2. So for me, this has landed at 532 centimeters. And there is my answer. Part C. Another boy has a best high jump of 195 centimeters. Give a reason why you should not use a line of best fit to estimate his best long jump. Well, 195 is much higher than all of the other points. Technically, this is something called extrapolating, which means that we are trying to use a point of data that's outside the range of values we have, and therefore it's not allowed. A line of best fit is really only valid between the points of data that we have. So anything above 185, we wouldn't be allowed to use a line of best fit to estimate. So any answer to this sort of question is involving the point being too high, or there not being enough data up in that area, or that this person jumped further than anyone else, and therefore the line of best fit is not allowed to be used. Question 26. A car journey is in 2 stages. Stage 1, the car travels 110 miles in 2 hours. Stage 2, the car travels 44 miles at the same average speed as stage 1. Work out the time for stage 2. Give your answer in minutes. So the first thing we're going to do is work out what the average speed is in stage 1. For me, I'm going to be writing this down that I do 110 miles, and I do that in 2 hours. Speed we often measure using miles per hour, so per hour means we want to get this to be 1 hour. To get from 2 hours to 1 hour, we are halving the amount, dividing by 2, which means on the other side we can also divide by 2 to give us 55 miles per hour. Now we need to deal with stage 2. The car is travelling 44 miles at this same speed. So we need to work this out. Now the hints that we have to change one of the units is that it's telling us to give our answer in minutes. So far our time unit is hours, so our next step is to change that into minutes. So 55 miles, instead of it being 1 hour, is going to be 60 minutes. There are 60 minutes in 1 hour. Now we've got a ratio of 55 to 60. These can be divided by 5, because they are both in the 5 times table. Once we have done that, that means 11 miles is being done in 12 minutes. And finally, since we want to get this to be 44 miles, we can multiply this answer by 4, and so 12 times 4 is 48 minutes. So the time for stage 2 is 48 minutes. Question 27. Here is an identity. A, with 3x minus 10 in brackets, is always equal to 21x plus 2b. Work out the values of A and B. So an identity is very similar to a normal equation. These two separate sides are equal to each other. The only thing that's different is that an identity says these are always going to be equal to each other no matter what value of x we put in. We now need to work out the values of A and B. Well, on the left, we've got a bracket that we can expand. Now for me, when I'm expanding a bracket, I use a grid method. Now the way that works is that I've got one single item in the A, and I've got 2 items inside the bracket, a 3x and a minus 10. So I start by drawing a 1 by 2 grid. The A is the one single item here, the 3x is here, and the minus 10 is here. That's just telling me and showing me very clearly what I'm supposed to be multiplying to get the answers to these 2 boxes. So for this box, we are literally going to be doing A times by 3x. The nice thing about this question though is that since we know that A with 3x minus 10 in brackets multiplied together is 21x plus 2b, I actually already know what the answer is going to be. that has to come out at 21x, and this has to come out at 2b, a positive 2b. And we can now work out what some of these numbers are. We can work out what a is because we know that when we take this number, whatever it is, and multiply it by 3x, I'm going to end up with 21x, which means that a has to be 7. 7 times 3x is 21x, so immediately we can say that a is 7. Since we know that a is 7, then the value of this box here is going to be 7 multiplied by minus 10. So this bit, 7 times minus 10, must be equal to minus 70. So I can write down an equation to say that we know that the value of 2b must be equal to minus 70. And so if I want to work out what just 1b is worth, I can divide that by 2. And that has to be done on both sides. So minus 70 divided by 2 is minus 35. And so our final answers are that a is equal to 7 and b is equal to minus 35. Question 28. J and K are ships. P is a port. J is due south of P. Angle JPK equals 56 degrees, and JP is equal to KP. Work out the bearing of J from K. So first of all, a bearing. A bearing is an angle that's measured clockwise from north using 3 digits. So we need to first of all figure out which bearing we are trying to find. So the bearing is of J from K, which means we're starting from K. So imagine that you are positioned at K and we're trying to get to J. But we need to measure this from north, clockwise, until we're reaching J. So we're trying to find out the size of this angle. That's our endpoint. To do that, we need to work out what these two angles are going to be. So first of all, JPK, since the distance of J to P and P to K are the same, these are going to be isosceles triangles. Okay, so this is an isosceles triangle with an angle of 56 degrees given, which means that these two angles at the bottom are going to be the same as each other. Angles in a triangle have to add up to give 180. So 180 minus the 56 is 124. 124 must be the total of those two angles, so we can take 124, divide it by 2, and say that each of those angles must be 62 degrees. That's 62, and so is that. We now need to work out this missing angle here. Since we know that J is due south of P, that means that P is also directly north of J. And since we have two north lines, those lines are going to be parallel. So that line there is parallel to that line there. When we have parallel lines, we will also have a combination of alternate and or corresponding angles. So for this, if I go up this parallel line, down towards K, and up towards the north, we are forming what looks like a Z shape. That is an alternate angle, meaning that this angle here is alternate to this 56, so that is also equal to 56. Those are alternate angles being equal. And finally, to work out our bearing, in total, angles around a point must total 360. If I subtract the 62 and the 56 from that 360, we'll get an angle of 242, and that is the bearing. So the bearing is 242 degrees from K. Question 29. The fifth term of a linear sequence is 17. The sixth term is 21. Work out the 100th term. Well, we've got no idea what the first, second, third or fourth terms are, but we know that the fifth term is 17 and the sixth term is 21. The best way that we can find out what the 100th term is to find out an expression for the nth term. So to be clear what that is, the letter n for nth term is a number, like fourth term or fifth term. In this case, it's 100th term. The word term itself means position, which is why I placed 17 in the fifth position. It's going to be the fifth number of the sequence, and 21 is the sixth. When I'm thinking about how to actually find the expression for nth term, I think about it as being a times table followed by some sort of shift upwards or downwards. So we need to identify which times table this sequence is based on. And we do that by figuring out how much it's going up by. This sequence is going up by 4. Now there is only one times table in the entire world that goes up by 4, and that's the 4 times table. 4 times table was 4, 8, 12, 16, always goes up by 4. So this is the 4 times table. Now a times table basically works by you taking 4 and timesing it by a number. 4 times 1, 4 times 2. In algebra, and especially nth term, we're saying the letter n is representing that number. So this is 4 multiplied by a number. That's the 4 times table. We then need to figure out how much this is shifted by. Now you can, if you want, work out what these numbers are. Yeah, so if we go down by 4, you could say that that is 13, that's going to be 9, that's going to be 5, and that's going to be 1, but you don't need to. If we know this is the 4 times table, then you should be able to know what the fifth number in the 4 times table is. 4 times 5 is 20. 4 times 6 is 24. And you can figure out then how much this sequence has been shifted. The 4 times table has been shifted 3 numbers down. You can see this working from all the others, because if we had 4, 8, 12 and 16, to get from the 4 times table to our sequence, we're taking it 3 numbers lower than it started at. And so -3 is the shift. This is the 4 times table, but 3 numbers lower in every case. Now we can use this. To work out the 100th term, that means we want the 100th number. So n is going to be worth 100, so 4 times 100, and then we're going to -3. 4 times 100 is 400, and 400 minus 3 is 397. And so 397 is the 100th term of the sequence. Question 30. The vector A is 2, 7. The vector B is 5 minus 2. Work out 3A plus B. Now, to understand what vectors are doing, first of all, understand exactly what they mean. So a vector is often used in the topic of transformations to do translation. It's a movement of a shape, a certain number of spaces to the right or left, and a certain number of spaces up or down. The top number in the vector is telling you how far you are moving in a horizontal direction. If the number is positive, you're moving something to the right. If it's negative, you're moving it to the left. The bottom number represents vertical movement. If the bottom number is positive, you're moving a shape up. If it is negative, you're moving it down. Now we can apply it to this question. 3A means that we are completing the movement of A 3 times. Well, think about what that would mean. That means that we are moving 2 to the right 3 times, which means in total that should be 6 to the right. We are also moving 7 up 3 times. So 7 up a total of 3 times means that in total we will be going 21 up. From that, we are following up with a second movement that goes an extra 5 to the right, but then goes 2 down. And we are working out how far this has moved in total. So if we've gone 6 to the right and followed by another 5 to the right, means that we are in total doing 11 to the right. And on the bottom, if we're moving 21 spaces up, but then come 2 spaces down, we've only ended up moving 19 spaces up. And so the vector of 11, 19 is our final answer. And finally, question 31. The value of a house is £120,000. The value is expected to increase by 5% each year. Work out the expected value after 4 years. Give your answer to 2 significant figures. You must show your working. This question is a question of compound interest. So that means that you are working out an increase of a value for the first year, and then that price is going to be increased by another 5% for the second year. Now you can do this one of 2 ways, depending on how confident you are with percentages. I'll show you the start of the longer method, and then I'll show you the quicker method as well. So in year 1, at the start of the year, the value of the house was £120,000. We then need to work out 5% of this. So 10% is going to be 12,000, and so 5% is going to be 6,000. So at the end of the year, the value of the house is the original 120,000 plus the extra 5%, which is now going to be £126,000. When we get into year 2, the starting value of this house is no longer 120,000, because at the end of year 1 it was 126,000, and you then need to start again. 10% of that is going to be 12,600, 5% is 6,300, and so the value in year 2 would be £132,300. And you would repeat that method for year 3 and year 4, always using this final value. The second method, which is slightly easier, especially on a calculator paper, is to use something called a multiplier. Now, a multiplier is a decimal that you can multiply something by to affect a percentage change. So to understand how the multiplier works, think about what this is actually doing. We're taking the value of a house, which is deemed at 100%. We are then increasing it by 5%, and that is going to give us a grand total of 105% of the original value. As a decimal, 105%, if we divide that by 100, is 1.05. This is the multiplier to increase something by 5%. So if we took 120,000 and multiplied it by 1.05, we will get £126,000. If we then took the £126,000 and multiply it by 1.05, we get the second year total of 132,300. If we then repeat this For the third year, we'll get 138,915. And for the fourth year, which will be the value of the house we're looking for, is £145,860.75. Now we need to give this answer to two significant figures. Significant figures are the most important significant values to give a number its size. So if we've got a number like this, the most important number is the 1. Because if that changes up to a 2, we're dealing with an effect of £100,000 being added on, which is a much more significant value than if the 7 changed, which is only be 10p difference if that went up to 8. That's even more significant than even the 5. If that changes up to a 6, that's only 1 pence. So the most significant change is the 1. So that is the first significant figure. The second significant figure will be the 4. And so these are our two significant figures, the 1 and the 4. We then need to round this. So we look at the 5 after the 4 and determine whether that makes us round this number up or whether it doesn't. 5 or above makes us round it up. So the 1 and the 4, the 14, will become a 15. And then we need zeros to make it the right size, because that 1 has to represent 100,000s. So we need to add another 4 zeros onto the end of this to give the total value to two significant figures as £150,000. That's the end of this exam paper. I hope it was useful.